Here we have the indefinite integral of the square root of 9 minus 16 squared dividing by x squared. And we want to find this indefinite integral using trigonometric substitution. And for this type of problem, to use trigonometric substitution, let's go ahead and factor out the 16. So to factor out the 16, we just put the 16 in front of the parentheses here, and then just divide everything by 16. So 9 dividing by 16 is 9 over 16. And then 16x squared dividing by 16 is just x squared. And then we can check it. 9 is 16 times 9 over 16, that's just 9. And then 16 times x squared is just 16x squared. The square root of 16 is 4, so we can go ahead and move the 4 and place it in front of the integral sign. And then we have this right here, the square root of 9 over 16 squared, or 9 over 16 minus x squared. And this is the form of a squared minus x squared. When using trigonometric substitution, then the suggestion is as follows. If we have expression like the square root of a squared minus x squared, then the suggestion is to let x be a sine theta. If we have the square root of a squared plus x squared, then let x be a tangent of theta. And then if we have the square root of x squared minus a squared, then let x be a secant of theta. For our example here, we have this. We have the square root of a squared minus x squared. So we will let x be a sine theta. And so in this case, the a squared will be 9 over 16. So we let a squared be 9 over 16, and then a to be the square root of 9 over 16, which is 3 over 4. So a squared is 9 over 16, and if we take the square root of both sides, and then a will be 3 over 4. And so now we let x be a sine of theta, so x will be 3/4 times sine of theta. And then the derivative of x with respect to theta, so just take the derivative here, we get 3/4, and then the derivative of sine of theta is just cosine of theta. And therefore we have dx is 3/4 times cosine of theta times d theta. And so now we need to write this integral right here in terms of theta. And so let's go ahead and write the expression 9 over 16 minus x squared in terms of theta. So we have x is 3/4 sine of theta. So in the place of x, we put 3/4 sine of theta. And this becomes 9 over 16, and then 3/4 squared is 9 over 16, and sine squared is sine squared. So this right here, we get 9/16 sine squared. The common factor here is 9 over 16, so we get 9 over 16. We get 9 over 16 times 1 minus sine squared. But 1 minus sine squared is cosine squared. And so we get the square root of 9 over 16, which is 3 over 4. And then the square root of cosine squared is just cosine. And therefore the expression square root of 9 over 16 minus x squared is 3 over 4 times cosine of theta. And so the this integral right here, the square root of 9 over 16 minus x squared becomes 3 over 4 times cosine of theta. X is 3 over 4, 3/4 sine theta, and so x squared would be 3/4 sine of theta squared. Dx is 3/4 cosine theta d theta. So in the place of dx, we have 3/4 cosine of theta d theta. 3/4 cosine of theta times 3/4 cosine of theta becomes 3/4 cosine of theta squared. On the top here we have 3/4 squared. On the bottom we also have 3/4 squared. So that would be 1. So 3/4 squared divided by 3/4 squared would be 1. And what's left is cosine squared for the top, cosine, and then sine squared for the bottom. So the integral here becomes 4 times the integral of cosine squared divided by sine squared. But cosine squared divided by sine squared is cotangent squared. So this becomes cotangent squared. And now let's go find the integral of cotangent squared. The derivative of cotangent of x plus x. Derivative of cotangent of x is negative cosecant squared. Derivative of x is 1. We can rewrite this as negative cosecant squared minus 1. So we can check here, if we multiply this back out, we get negative cosecant squared plus 1. But from trigonometry identities, we cosecant squared minus 1 is cotangent squared. And so the derivative of cotangent of x plus x is negative cotangent squared x. And so the antiderivative of negative cotangent squared x dx will be cotangent x plus x. We can move the negative sign here and place it in front of the integral, and then multiply both sides by negative 1. Then we get integral of cotangent squared of x is negative cotangent of x minus x. So the antiderivative of cotangent squared of x is negative cotangent of x minus x. And so the antiderivative of cotangent theta squared will be negative cotangent of theta minus theta. And then multiply this out, we get negative 4 cotangent of theta minus 4 theta. But this is theta. The original problem was in terms of x, so we need to rewrite this in terms of x. Earlier we have x equal to 3/4 times sine of theta. So we have x equal to 3/4 sine of theta. which means sine of theta is 4x over 3. So right here, multiply both sides by 4/3. So multiply the left side by 4/3, multiply the right side by 4/3. And we get sine of theta is 4x over 3. And then by definition of inverse sine function, we get theta is sine inverse of 4x over 3. But the answer here involves cotangent of theta. In the place of theta, we can put sine inverse of 4x over 3, but we need to find cotangent of theta. Sine of theta is 4x over 3. Definition of sine is opposite over hypotenuse. So we have sine of theta is 4x over 3. This is the angle theta, opposite over hypotenuse. So the opposite side will be 4x. The hypotenuse will be 3. And we need to figure out the adjacent side. From the right triangle, we have a squared, and then plus 4x squared is equal to 3 squared. So we get a squared plus 16x squared equal to 9. Or a squared is equal to 9 minus 16x squared. And then take the square root of both sides. We get a to be the square root of 9 minus 16x squared. And so the adjacent side here will be 9, the square root of 9 minus 16 squared. Cotangent is adjacent over opposite. And so it would be the square root of 9 minus 16x squared dividing by 4x. So that's cotangent of theta. We want to convert, we want to write negative 4 cotangent of theta minus 4 theta in terms of x. In the place of cotangent of theta, we will have the square root of 9 minus x squared dividing by 4x. And in the place of theta, we have sine inverse of 4x dividing by 3. So in the place of cotangent of theta, we have the square root of 9 minus 16x squared dividing by 4x. In the place of theta, we have sine inverse of 4x dividing by 3. 4 dividing by 4 is 1. 4 dividing by 4 is 1. And so we end up with negative square root of 9 minus 16x squared divided by x. And then minus 4 sine inverse of 4x divided by 3. So this is the answer.